Okay, so the last lecture in our discussion about the chemical basis of life are acids and bases. So we should be familiar. We have heard the term pH scale before, right? What does that mean? So pH is this potential of hydrogen, and it's a scale that runs from 1 to 14, and it's basically telling you how many hydrogen ions or hydroxide ions are in a solution. And so the lower numbers below 7 responds to acidic, and the higher numbers above 7 go to alkaline. Okay, so potential of hydrogen. How many hydrogen ions do you have? And so the more hydrogen ions, you're going to be acidic. The least hydrogen atoms or ions, you're going to be basic. And when you're basic, it's a flip-flop between having hydrogen and hydroxide. And if you look at these H2O, right, this is breaking water molecules apart and saying when you put a solution in water and water starts to dissolve it, what are you left with, hydrogen ions or hydroxy ions? And if you have an equal amount, you're at 7. So when water dissociates, it releases those H2 or those H and OHs, right? And so this is, again, remember that dynamic process. So you have this water and it's coming apart, reforming, and you get these H positives and these O minuses, OH negatives. So if it's neutral and it dissociates, you have an equal number. So you see 1 water molecule, 2 water molecules, 3 water molecules, 2 H's, 2 OH's. This is a neutral solution. But if you add the acids to it, it's going to increase how many H positives you have. So when you have an increase in H pluses, it's an acidic compound and it has a pH below 7. And on the flip side, if you put it in the water and you have a little amount of H's or a larger amount of OH negative, it's a basic solution and it has a higher pH. And sometimes bases are called alkalines. Now, this should be intuitive if you want to neutralize an acid. So if you have a lot of H positives in a solution, you need to add those OHs, and you get those OHs by adding a base, yes? And then if you want to neutralize a base, so now you have a lot of OHs, and if you add an acid, it's going to have a lot of H pluses, and you put that in there, and you can neutralize it. So if you have an acidic compound, and you want to get it to 7, so you have a low pH, you want to raise it to 7, you start to add some base to it. If you have a high pH, you want to reduce it to 7, you start to add acid to it. And now, by now, you should be able to take these terms and put them on the pH scale in the correct place, right? So pause the video and see if you remember anything. Welcome back. And so now you should have something that looks like this. So we know that 7 is neutral. Anything below 7, so 0 to 6.9 is going to be acidic. Anything above 7.1 to 14, those are your basics, okay? If it's acidic, it's going to have this high H plus. So the higher the H positive, the lower the number. The higher the OH, the higher the number. Why do you care? Why am I even spending time telling you about pH? Well, our body has a pH, and it's not the same all over the body, okay? So you would think, hey, our body should be neutral, right? But no, it's slightly alkaline. And I'm sure you've seen them advertising like alkaline water. So we have a slightly alkaline to our bodies overall. And so we are a little above 7, a little above neutral. But guess what? In the stomach, it's very acidic. So it has a pH down here of almost 1. But that's what the stomach needs to do its job. When you will look at lysosomes and peroxisomes, they're going to have a different pH inside, okay? But the cell should be slightly alkaline, but certain parts of that cell might have a different pH. And pH is important too because foods we eat can change our pH. If you are sick or healthy, it can change your pH. So we know, and you talk about things like lemons and citruses, orange juice and things, and how they are acidic and can mess up your teeth, right? But then you see milk is almost neutral. And then we have our basics, and we're finding this in a lot of our household cleaners, ammonia, bleach, oven cleaner. Those things are base. And then you should also care too, because you could burn yourself or something by having too acidic or too basic of a mixture. Why else do you care? How many of us have heard about heartburn? What is that? That's that acidic stomach contents coming up the esophagus where it shouldn't be. So the stomach is coated so that it can maintain its acidic environment. Outside of the stomach is not. So if that acid goes up into your esophagus, it really is burning that lining because it wasn't made to have that acid in it. And so if it's too acidic, what do? How do you relieve heartburn? You take a base, okay? So this Tums is calcium carbonate. It's a base. And you take it, and it helps to then reduce that acid that's found its way into your esophagus and get rid of that heartburn. Why else should you care? In the atmosphere around us, you can look at some trees and see that acid has affected them. And this is because of acid rain. So another important part of having, or another consequence, I should say, of global warming is putting all these carbon dioxides and things in the air. It has to come back down. So as we are changing the pH of our environment, it's giving us more acidic rain. That rain is falling into our oceans, making it more acidic, which will ultimately affect our aquatic life. You can look at some statues if you get a chance to go into DC or things, or even old buildings in towns that were made of marble or something, limescale, something close to it. You'll see the color it takes on. If you look at monuments and things, you'll see like the noses start to chip away. A lot of that stuff is caused by acid rain. So pH it's important to our bodies and to the environment around us.